This video is going to run through the concepts that were assessed on the most recent quiz, which was properties of exponents. Like usual, when you're doing this video, I would highly suggest you pause it, try out the problems ahead of time, and then check your answer based on my answers and explanations. Okay, here we go. So in the tables, the tables are set up, there's patterns going on everywhere, right? You see the pattern here, you see the pattern here. You might not see the pattern here yet, but you will see one. You see a pattern here, and likewise you might not see the pattern going on here yet, but you will, okay? So we're squaring all these numbers, and squaring just means multiply the number times itself. So this is 1 times 1, 2 times 2, 3 times 3, 4 times 4, etc. And I'm just going to fill those in. You should have these memorized. If you don't, off to the side, like if you don't know what 11 times 11 is, you're just going to have to multiply 11 times 11 and work that out the long way, because you're not allowed to use your calculators on this. Okay, so there are all those numbers squared. Over here, notice the exponent didn't change on this one, square, but the base number did change. On this one, the reverse of that's happening. The base number is always 2 on these. It's the exponent that changes. So why is 2 to the 5th 32? Because 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay? 2 to the 4th. 2 times 2, 4, 8, 16. 2 cubed, 2 times 2 is 4, times 2 is 8. And then you could keep doing that, but you see this pattern emerging here. And the pattern seems to be you're multiplying by 1 less 2 each time, right? So this is 2 times 2, which is 4, and this is 2 to the 1st, which is 2. And then be careful here. All right, some of you already know what's going to be happening. Let's just finish this pattern here. The base number is always a 2. It's the exponent that's changing. Look at the pattern. Doesn't this seem to be dividing by 2 every time? So let's continue that pattern. 4 divided by 2 is 2. What's 2 divided by 2? 1. What's 1 divided by 2? 1/2. So the original meaning of exponents, like 2 to the 5th, that is 5 2's multiplied together. The original meaning of exponents kind of goes away here, but that doesn't mean there's not a solution. And we know there's solutions because it has to fit the pattern. So 1/2 divided by 2. Okay, and we get those filled in. And then we see there's a relationship here. If we think about this as a center point, look at the relationship here. 2 to the 1st is 2. 2 to the negative 1st is 1/2. Do you see how 1/2 is the reciprocal of 2? 2 as a fraction would look like 2 over 1. If you take the reciprocal of that, if you flip it, you get 1/2. So we start to think about this negative sign as in the exponent as a reciprocal. So 2 to the 1st is 2. 2 to the negative 1st is the reciprocal of 2. Notice how that pattern stays true here. 2 to the negative 2, it's the reciprocal of 2 squared. So 4, the reciprocal is 1/4. Okay, so let's fill in the left hand. There's a pattern here. The base number stays the same. It's the exponent that changes, but there's a pattern involved in that. Okay, that's done. And then 1/5 to the 1st power means 1/5. 1/5 squared means 1/5 times 1/5. That's 1/25. 1/5 cubed is 1/5 times 1/5 times 1/5, which is 1 times 1 times 1. 5 times 5 times 5. And you might be saying, well, here's 4 5's being multiplied together, but what's 5 5s being multiplied together. It's 625 times another 5. I don't know what that is in my head. 5, 2, it's 10, 12, carry the 1, 31. So that's 3125. I guess I could have cheated and looked down here, right? So what's 1/5 to the 0? Anything to the 0 power is 1. We kind of looked at that over here. There's the reciprocal of 1/5. So here's where what's the reciprocal of 1/5? Flip that fraction. It's 5 over 1, or just plain old 5. Here's 1/5 to the negative 2. What's the reciprocal of this one? What's the reciprocal of this? It's 25, and then you can see the pattern happening. 125, 625. All right, done with the tables. So practice that, understand the concept, and you'll be able to do those pretty quickly. There's shortcuts to all these. I'm not going to talk about the shortcuts. I'll kind of point them out, but I'm not going to focus on those, because if you know what the properties of exponents are, you don't have to remember any of these shortcuts. 3 to the 8th. Times 3 to the 4th. I don't write all these out when I'm taking a quiz. I can picture 8 3s being multiplied together in my head. You can too. And 4 3s being multiplied together for a total of 12 3s being multiplied together. And the easiest way to write that is in exponential form. No calculators on this, so you're not going to be allowed to, multiply that out and get whatever big number that is. 2 to the 5th cubed means 2 to the 5th times 2 to the 5th times 2 to the 5th. There's 5 2s being multiplied together, another 5 2s, and another 5 2s, and that means there are 15 2s being multiplied together. 5 to the negative 2, that is the reciprocal, remember that negative exponent, of 5. What's 5 squared? 25. What's the reciprocal of 5 squared? 1 over 25. On the divisions, what you want to do is, again, I don't write these out usually. I just imagine 1, 2, 3, 4, 5, 6, 7. 7 4s being multiplied together on the top, and down on the bottom 2 4s. And when they cancel, there are 5 4s left in the numerator. So that's 4 to the 5th. 2 to the negative 5th. Okay, reciprocal. 2 to the 5th is 32. 2 to the negative 5th is 1 over 32. This is the reciprocal of 5 cubed. There's the reciprocal of 5 cubed. Here's 5 to the 5th in the numerator. I'm picturing 5 5s on the top and 3 5s on the bottom, and they cancel, and we're left with 2 5s on the top. This one, write it out. It's very similar to this one. So you can write out 3 squared times 3 squared times 3. Do that. Take a minute, pause the video, write down your answer. This one, imagine, and if you need to write it out, go ahead and pause it again. 11 6s on the top, 13 6s on the bottom. Write those out and cancel whatever would cancel. And what's left, and where are they? There would be 2 6s left on the bottom. Or 1 over 36 would also be good. This is the reciprocal of 2 to the 8th, and this is 2 to the 4th. So imagine all those 2's and canceling, what's left? 1 over 2 to the 4th, or 1/16 would work. Picture this one. This is a like base technique. Usually it's easier to make the larger base look like the smaller base. So instead of 4, we're writing 4. Look in red. That still says 4 squared, just like that says 4 squared. And so this ends up being 2 to the 4th times 2 cubed, which is 2 to the 7th. Like base technique again. Instead of 27 squared over 3 to the 5th, what's 27? 27. Imagine those 3's canceling. What's left? 3. All right. This is solving equations using the like base technique. These bases are already the same. These are not. Okay? If the bases are the same, it's an equation. It's a perfect balance. If the bases are the same, the exponents have to be the same to make this balance perfect. So bases are the same. We're going to say, well, the exponents have to be the same. And if you solve that for x, you get 2. Take a minute and do that. This one, the bases are not the same. It's usually easier to make the bigger base look like the smaller base. So I'm going to keep that small base there. That bigger base, 64, there's 64 right there. But I'm using a base of 8 now. Power to a power, we're going to multiply those exponents. So 8 to the 3x equals 8 to the 2x plus 6. If the bases are the same, the exponents have to be the same. Write them out. And again, hopefully I'm going really fast here. So if you need to, if you forgot, if you're just like in a daze and just watching this video, don't just watch it. Pause it on each problem, try it out, and then run through and check your answer. Bases are the same, exponents must be the same. Solve it. All right, that's it. If you were unhappy with your quiz score, remember you can come back and retake it.